a week from the previous session. Feel free to chip it in as we hold on for others.
Okay.
Okay.
Thank you.
All right. Likewise for Caroline. So Steve, I think we'll continue with that. But as you mentioned, because enterprise development is part of the design phase, it comes back also and fits into that. So probably to the team and us, that could be our task also for the design, to look at the enterprise development side of things of the academy.
Yes, and maybe we could use some of our participants as clients, to help us understand what we can do,
Yeah, or alternatively switch positions, do a role play and switch positions. Have them as the consultant or the service providers.
Well, yes. I mean, so as we move into, so this is session 13 of our 24-week PDC. So we've just passed the halfway point. And that means that our theme for this session the next week is informed by David Holmgren's Principle 7, which is the icon of which is a spider's web. And the principle is design from patterns to detail. And actually, this is what a PDC is. In the PDC, we're teaching you the patterns, not the details. The details of farming and gardening and food forests and soil biology and making compost and energy and buildings and finances and local economies. There's a lot of complexity to that. What we're trying to give you is the overview to get an understanding of, so you start by seeing the pattern and then you slowly focus into the detail. And so we're going to start thinking about patterns in a more general way. And then we're also going to talk about patterns in design, because that's what this course is about, is we're teaching you how to design using nature as a template to create abundance, to build systems that can sustain themselves, are built from local and natural resources and don't need constant inputs from outside to be able to survive. That's what permaculture design is. That's what we're trying to take you towards. And so it's all very well talking about these ideas, but the question is, how do we implement them? How do we make real changes in the real world? And I think key to that is to be able to communicate ideas in a way in which other people can also understand what it is that they can understand the idea, how they can be part of it, how they can contribute, and how they will benefit. So I think that's part of what we try and communicate in permaculture design. So off we go then, and let me just think for a second. Okay, I'm going to start. Let's start off with. Well, I've got some opening thoughts. So we'll start with those, seeing as that was what I had in mind earlier. So share screen. Okay, this is as much as to get me going as anything. So here we are, session 13 on our PDC. Opening thoughts about patterns and this idea of design from patterns to detail. Here's a pattern. This is the average temperatures for the land and sea, and how since 1850 they have risen significantly by a degree. This is climate change. Now, that's a pattern, and it's not going to go away. So whatever we are doing in our designing and planning, we have to realize that we've got to design things to be more resilient than before. What does that mean? Well, we can expect the pattern that we are seeing is we're having, slightly more extreme, more energized weather patterns. So that means sometimes it's drought, sometimes it's not enough rain, sometimes it's too much, or all the rain comes at once, or many subtle changes as well. We've got this is a pattern that is going on around us, and we need to sort of keep in mind. And this is a pattern that is going to inform our approach to design. We're going to have to think about in building, more resilience. We accept that in some ways conditions are going to change, and this might be a theme that we're going to have to keep coming back to. But so just to put that out there. I was just looking for patterns earlier to get us started, and this is the SDGs, the United Nations Sustainable Development Goals, and I quite like the idea of looking at these as a pattern, because again it informs how we approach design. And what this is saying is our design, our society, and our economy, our enterprises, our businesses, our strategies to meet our needs have to work in partnership with society, but they are limited. They are defined by the geophysical limits of the planet, the biosphere, the weather, the water, the soil, the atmospheric conditions, the life on land and the life below water. These are critical things which also frame our design. So we design from patterns to detail. So we're thinking about, yes, there's this changing background of this climate thing, and also our design needs to fit within this pattern of the way that we are as a planet, trying to see development as this in this way. So I thought that was useful. Okay, we're going to talk about zones and sectors. This is another basic pattern that we use a lot in permaculture design, and I find it one that's very useful. So, and the world's really big. How do we simplify it? How do we make sense of something that's big and vast and constantly changing? Well, here's a way of thinking about it. Let's simplify it, and let's just say there's 5 zones. Okay? The first zone is centered on your home, on where you are. And it might be the area inside and outside the home and around it. Let's call that zone 1, because that's the zone that you actually spend maybe the most time in. You notice the most things, you make more observations, you invest in it because it gives you benefits back. So if we have high maintenance activities, things that need our constant attention, it's quite a good place to do it is in the zone 1, just outside your house. Put the baby out to sleep, or have some sensitive seedlings that might need your attention. Grow a few herbs, perhaps for your cooking, or other things that you might need. Think about what you might place and locate in the zone 1, in this area around your home. Okay, so if we go slightly further out, the periphery of that might be your garden, or the extent of your further out into your compound, or an area where you might interact with other members of the community, a more communal space. What things might you find in a zone 2 space? Maybe things like, I don't know, things you might interact with not quite so often, But say there might be some fruit trees, there might be some, you might be growing some plants, a bit of a garden. You might have some small animals, some small livestock, and so forth. So as you move out beyond the house, beyond the compound, beyond the garden immediate area, we're going from zone 1 to zone 2 to zone 3. And zone 3 is, well, think about it as if you were a farmer, it's your fields, it's your main crop, or it's your job, it's where you go to work. So we go to zone 3 with a sense of purpose, and we might go there regularly, but to take our tools and to go out and work, and we can't fit everything around the house. So things that need a bit more space, and we're doing it at a bigger scale, and so forth. So that might be pasture and livestock, it might be dairy cows, and we might have the milking shed in zone 2, closer to the house. We might place elements into our zones so that they're to optimize them, so that we can maybe walk. As you walk from our house, you might go past our tool shed to get to the garden, so you arrive with your tools in your hand. So zone 4 is on a farm, on a garden. It's where you don't go very often. It's the fuel trees, or maybe a long, bigger orchard, or maybe a woodland you're growing for timber. The edges, the field boundaries, hedges, all of these things are zone 4. You might only go into zone 4 occasionally, and you might do seasonal harvesting or seasonal maintenance, but you tend to not put high maintenance things out on the periphery of your farm or your land or your plot. And zone 5 is everything else. Zone 5 is either wilderness, or the uncultivated, the wild, or it might be just land that you don't own, or it's beyond your control. And the idea about zone 5 is we might go into zone 5 to gain new ideas, to gain new perspectives, but we bring those ideas home and apply them in zone 1 and out. So we'll talk about this a bit more. I think this is a very powerful and important model. And the permaculture design idea sort of states is start from your back door and work outwards. Or in fact, start with yourself. Invest in yourself, you're learning new skills, new ideas, and you can take those ideas and apply them to your home. Apply them to the area around your home, to your garden, bring it into your work. See how slowly permaculture ideas, methodologies, inspirations can start to permeate every area of your life. And this zone 5 thing, the wilderness, the untamed, this turns out to be so important that in permaculture they sometimes suggest is you should have a bit of wilderness in every zone, have an ability for random associations to happen, things that you didn't plan. Again, all ideas that we can expand on as we go forward into the course. So thinking about patterns. Here's a temperature, here's a pattern of ideas and priorities. Here's a pattern of how we might place things on land according to how much we interact with them. Now, of course, the real world never looks like the pattern. Nobody's land is perfectly flat, and nobody's, I'm not saying your compound is completely round. These things never happen. This is the idea. In reality, that map might be twisted and shaped by the fact that there's a really steep hill behind the house here. So the zone 5, we've got a maybe woodland or something like that going across sort of a zone 4 and going in between a zone 1 and 2 areas. So that's the concept, and we can think about the kind of functions that we might put in different zones, and then also understand that the zones actually might look quite different from that according to the uniqueness of the place or other considerations. So this is what's the detail. There's a pattern, there's something a bit more detailed. And we're also going to talk about sectors, and there's kind of two key ideas here. Is if the zones are like concentric rings of a target going outwards, sectors are like slices of a pie. It might be access, it might be wildlife, it might be where the sun comes from, where the wind comes from. So we define sectors as energies. So it says here, on any site are powerful energies, both potentially beneficial and destructive. Wild energies like the wind, sun, the danger of fire, water, even wild animal flows, and use potentially, all impact on the property. So permaculture landscape design takes account of these through sector analysis. Once they are accounted for, and with placement of design components, they can be channeled for special uses, encouraged, minimized, blocked, deflected, aimed to conserve site energy, aesthetics, or resources. So in other words, if you know which side the wind's coming from, you know where to plant your windbreak. If you want, you can predict the movement of the sun. So you can ask yourself, the question is, do you want the entire side of your house to be, or do you want it to have solar gain? And depending on where you are in your latitude, that will change. These are patterns that we can see and then conform to. Do we want to have a solar gain or a solar minimum? That's for you as the designer to find out. And the design of the house is informed by its location, the orientation of the house, and its altitude and the height of the sun, and the height of the sun at different seasons. We're designing from patterns to detail. So sector planning deals with the energies that pass through a site. Good design moderates these energies. Is a little water as a drought, too much as a flood. So we need to minimize the excesses. And one of the ways we might do that is through creating microclimates, softening the edges, creating a range of conditions, rather than just, if the site is very windy, we can plant shelter belts, and that will reduce the wind. Some parts of the site might still be a bit windy, others might be much less. That creates then a range of opportunities. So this is how we should be thinking as we approach permaculture design. We're going to look at things and see the patterns. We're going to think about how that fits into other perhaps long-term goals, how we fit into the landscape, and then also the functions of the design that we want it to do. So a good principle, work from patterns to details. That's my opening thought. Please, if anybody wants to comment at any time, please do. Sometimes when I get going, I just carry on, but patterns in nature. So let's just have a think about generic patterns and types of pattern that we might see. And it's kind of interesting. So this is looking at a kind of broccoli, a kind of cabbage family plant, and we're seeing kind of fractal spirals. So this is a pattern that repeats on itself, and you see the same pattern but at lots of different scales. This is something we see. The more we look, the more we find these sort of kind of fractal type patterns. We flip over a lily leaf. So think about the function. What's so interesting is the lily leaf floats, right? And in fact, all seen that picture of like a small boy sat on a big lily pad, and they're very buoyant. So you can imagine that this is obviously turned upside down, and here's the ribs of the leaf. Look how these little pockets, and how obviously as the plant photosynthesizes, it gives off carbon dioxide, also give off oxygen, be coming out, and those little pockets will float. It would trap the air that's coming out as the plant is respiring, and it floats. So we can learn from that. We can look into that, and that's what we mean by learning from nature. Look at this very interesting material. Think about the function of the leaf, and think about how the form fulfills that function. Soap bubbles. So here's an interesting thing: is soap bubbles in the air obviously would be spherical, perfectly spherical, if there was no wind, I guess. And here we're seeing them squished together. So if you push lots of spheres together, look what shape you get. You get 1, 2, 3, 4, 5. Pentagon. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. We've got hexagons and pentagons. There's a perfect and lovely 5-sided one, 6-sided one, 6-sided one. That one's a bit squished. So we get 5s and 6s if you push circles together, and then you get something that's domed. That's interesting. We're just observing nature and asking, what are we learning? This is the eye of, I guess, a fly or possibly a mosquito. And what we're seeing is it's domed. It's a curved surface. And the cells on it are 6s, I think. Are they all 6s? Are they 6s and 5s? But look how we can seeing. So the same mathematics, the same forces that make soap bubbles form like that, somehow that's translated in through evolution into the shape of the lens of plants, because the molecules that are being shaped by the same forces, the same, so that we can look at a pattern in one circumstance and learn from it and apply that in another circumstance. That looks like the tail of a chameleon, and look at how interesting is the spiral pattern, and think about the function of this tail, how it might be prehensile, not to hold on and help with balance, and also look how the surface of the tail, so also it can move in different directions, is in all kinds of 5s and 6s. We've got the same sort of kind of patterning because we've got the same kind of function going on. So that's interesting, isn't it? Think about, so we can look into nature in so many different ways, and each time see again recurring patterns. Something is important about that, and something about, we can use those observations to build our own language of patterns. This is a dahlia, this is a flower. And look how each of these little tubes is offset from the others. So we've got a really interesting spatial arrangement. So there's no gaps. We've managed to fit in as many of these flower tubes into the space as possible, and fulfilling the function that the flower needs to do, obviously, for pollination. Creating surface area and optimizing the use of space. We can learn from that. This is called a sundew leaf. It's a plant with a sticky resin on it, and it catches insects that land on it and then digests them. Pardon me. Again, we're seeing that spiral, and this time with little drops on it. Perfect. hexagons of a wasp nest. It was a bee nest. A bee. It looks like a wasp to me. Anyway, we've all seen these patterns in nature, and think about how, so when you squash circles together on a flat plane, they become all hexagons. It's when you want it on a curved plane, they become 5s and 6s. You can learn from this. This is a tried and tested over millions of years of evolution to create the maximum strength for the minimum amount of resources to fulfill the particular function intended by the wasp or bee, whatever it is. Anyway, here's a centipede, a millipede, and look, it's curled up to protect itself. It's got its hardest armor on the outside and its vulnerable part where its legs are all tucked away. And by curling up like that, it's too big. It's hard for a bird to swallow it. So that's a defensive pattern. Now, when we look into the structure of plants, again, we see recurring patterns. And these patterns turn up again and again and again, and they're a product of the same mathematical formula. So wherever we're looking, and this is what we mean by how we can learn by observing nature, is it doesn't matter what the form is, we see universalities occurring in different places. So, okay, so there's, I think, 6 pattern archetypes that we're going to talk about, sort of a pattern of patterns. One is the branching pattern, and we will recognize this, the branch. Here's a river oasis. Sorry, river what do we call it? Delta. Sorry. So you can imagine as the river water, heavily laden with silt, starts to enter the sea, the water slows down, so the river starts depositing the silt, which makes the water go sideways. It keeps repeating that, and over time, the river moves around, but it's creating this branching pattern. So you can see that's a pattern of distribution. This is your lungs. I think is that the alveoli. So this is a pattern to create maximum surface area, so that we can exchange oxygen across the cell walls. Here's a dragon tree in the Canary Islands. Branching pattern. So think about this, a quite simple mathematical formula is you halve, there's your single stem, and then you halve the distance and you double the amount. So we're going from 1 to 4 to 8 to 16, and but each time it branches, it gets smaller and smaller. And look how we've gone through, using that very simple formula, we've gone from the simplicity, straightforwardness of a single stem of the trunk of the tree to the complexity of something that's divided and divided and divided. Now here's I think what's a fascinating lesson about patterns in nature is you can have the same tree, the same genetics in the same place, but the pattern that it creates is always unique. And it's like your fingerprints are, you can generalize about them, what type of shape they are, but that for each person, they're absolutely unique. So here's a way in which we might be able to think about permaculture design. You start off with a simple set of ideas and concepts. How do we live on the planet in a harmonious and abundant way? And then you break that down, ethics, principles, design tools. And then you start applying those ethics, principles, and design tools to the real world. And in the real world, the wind's blowing, and there's a bird just landed there. And one day it was hot, another day it was cold. The conditions are not always the same. So as the tree expresses its genes, as it unfolds, it's shaped by the wind, the sun, the rain, by the birds, the insects, the fungi, the changing weather patterns. So it's always going to be unique. And this is why it's going to go back to our icon for Principle 7, design from patterns to detail. The icon for that David Holmgren gives us is the spider's web. And you've all seen a spider's web. And if you come across one, you might say to yourself, aha, I see a spider's web. But the truth is, every different type of spider makes a different web. Each individual spider might make a different web. And certainly each individual spider makes a unique web according to the circumstance in which it made it on that particular day, and how the wind was blowing, and a fly flew into it and changed the shape of it. So permaculture gives you these tools and these ideas, and you're going to take them away and you're going to create something unique that's going to meet the needs of the intended beneficiary of your design, of your client. It might be you, it might be your community, it might be your family, it might be your school. So you're going to take these ideas and they will manifest themselves in their own unique way. Okay, branching patterns. Also roots, think about that, creating surface area, creating the function of holding on to something. We can learn from these. We can apply them. So this is really interesting. Obviously, this is seawater lapping forward and back on the beach, and it's creating the same little patterns in that you might recognize as erosion gullies, but just doing it on a micro scale. Look, these little rills, see how they quickly join together and create a bigger erosion feature. And then we're seeing the deposit of the sand down at the bottom. So we're having erosion at the top half and deposition at the bottom. And you can see that pattern in a little bit of water movement over sand, or you can see it on a whole mountainside, and you can understand what's happening. And you can say, aha, I see the pattern. Now I can begin to think about the detail about how we work with that, how we understand it. So more patterns, more water movement patterns. And you see how you can quickly identify and interpret these and understand what you're looking at. The lobe, I always want to see a cluster of insect eggs, butterfly eggs or something, when I think of this pattern. So lots of different elements crowded together that maybe have a function as a whole as well. So penguins crowding together to keep warm or to protect themselves. Or here we have the lining of the gut. This is the large intestine, which has lobes which create huge amounts of surface area. I wondered about the shape of a city and think about how each one of these lobes it's an element in itself. It's a unique element in itself that's clustered together with other ones that have the same function. And then that creates another sort of a third environment, the streets, the roads, the protection of the shade in between them. So a unique set of environments happening actually in and within each lobe, and also then between them and the outside, the inside. We're creating many, many different environments and lots of surface area. These are design pattern archetypes, really. So it's a dry stone wall. There's crinkle shaped of a kale plant. Pumpkin leaves, elements crowded together, each one unique, each one responding to the light and the environment, trying to optimize it. But look how they don't overshadow each other, that they've optimized their position so that one leaf isn't really shading out another one. It's a lobed pattern. Here's an idea. The difference between a straight path the advantage of this, and this straight path across my garden, is that it gets me from A to B, from one side to the other, as quickly as possible. Excellent. Well, we're also kind of interested in edges and surface area, aren't we? And the way to create edges and surface area is to have sort of more three-dimensional complex shapes. So if we just go back into 2D and think simplistically, if I have a curved path, there's now much more interaction between the path is for the person, the green, the garden is for the plants. So as I walk through here as a gardener, I'm interacting with much more of the garden. So this is an edge effect. And I tend to, if I'm walking on the path and I see something, I'm more likely to interact with it, to pick that fruit, to take that weed, or interact with the garden in some way. But now I've got the problem is, yes, I'm interacting with my garden, but if I'm just want to go forward and back to carry materials, I've got to walk this long, circuitous way. So an idea we brought into permaculture is like a lobed path or a keyhole path. So we can still got our straight line direction to get us from A to B, from top to bottom, should we need to. But we've also got access path or patterning to create an edge between me, the gardener, and the garden and the land around it. And remember how we said, we mustn't compact the soil. That's why we like to have raised beds. It's why so that we can build soil up and not stand on it. So if we've got carefully arranged elements, our path like this, so that we can, when we're from this point, we can reach all the way around. We can garden all around without ever touching, standing on the soil, without ever compacting it. So lobed paths, thinking how that might create a repeating pattern, a nice mandala garden type pattern, and think about how we can have as much garden to minimum path, maximum garden, and strategically placed elements so that we can reach everywhere and we can gain maximum benefit. So lobes, patterns, very interesting what we can do with that. So look, this is what we saw with when we looked at the eyes of the insects and of the plants, was instead of being in straight lines, things were staggered, slightly offset. You can fit more elements in. We can get another 16 trees in this little example here, or plants, by offsetting them. And also that might make the whole design much stronger because the elements are then closer to each other, reducing, say, wind flow or other considerations. So patterning and placement to create edge, to fit things in. There's our eye of a fly again, and we're seeing again the same mixtures of mainly hexagons. But we've got some fives and sixes to create that curved surface. And then of course we have the spiral, our third pattern archetype. And we saw that with the tail of the chameleon and the curled up centipede. So what's interesting is, and again, this pattern that we see in a lot of leaves and patterning, is there's a numeric relationship underpinning some of this pattern formation. So mathematics creates patterns. The elements in our world are being subjected to the same forces of physics, and so that's why the same patterns reoccur all the time. So this is a very interesting pattern. Is we start with 0 and we add 0 to 1, the answer is 1. If we go back and we add 1 to 1, that generates the number 2. If we add 1 and 2, that generates the number 3. If we add 2 and 3, that generates the number 5. If we generate 5 and 8, sorry, 5 and 3, that gives us 8. 5 and 8 gives us 13. That in itself is a pattern, and so you just keep adding the product to the number before. So that the next one would be 13 and 8, 21. So on we go. So and it's interesting because that numeric sequence, if you plot it on a graph, creates a spiral. And somehow we see this. This is called the Fibonacci series, named after a mathematician who first described it. And we see it in nature, we see it in art, we see it kind of everywhere. We see it in our vegetables. We see it when we look into space, into the universe. See the structure of galaxies, the unrolling of a fresh leaf, the spatial relationship even between our fingers and our arms. It fits the same ratios. So that we then bring these ideas into art and expression and into design. Fibonacci series. Well, this is something which will come up again and again, and it's a very interesting thing to open up on. Spirals are really important and powerful shape, and we'll dwell on that a bit more when we get to principle 9, small and slow solutions. Yes. Okay. I put this pattern in. I'll come back to it. This is a piece of cave art in Uganda, and I've always found it very interesting. But I think we'll come back to that. So we said now, pattern archetypes. You see a pattern of patterns. Okay, there's that branching pattern that we see in trees, in our lungs, in our circulation, and so in rivers. Branching pattern. There's a low pattern. That's lots of individual things but clustered together. There's the spiral, the Fibonacci pattern, and there's the net. One that there's a spider's web. Look how. Well, it'll be instantly noticed the spider's web is, but look how it's actually quite idiosyncratic. It's got a lot of detail in the middle, and then it's this kind of bit of blank space. Maybe it's more structural further out. I don't know. But we instantly see the pattern, and then we slowly zoom in onto the detail of it. And the net is, well, it's designed to catch something. It's trying to create a maximum surface area. The maximum possibility of catching something by, again, using the minimum amount of materials. So it has to have the desired effect, and obviously the size and strength of the web would reflect the size and the weight of the kinds of insects the spider was hoping to catch. Designed to fulfill function. And yeah, so the net. Obviously, let's think. Well, this was a structural pattern of a roof, a self-supporting roof. Ripples of water, mycelium. Thinking about covering a lot of areas. Made us think about computer systems, connecting lots of different things together in lots of different directions. How servers and systems might work, and how isn't it interesting that they look so much like fungal mycelium? That maybe the internet, which is what this is a map of, functions very much like so there's lots to be thought of here. There's lots to be learned. This is a map of an ecosystem. And look at these are different elements. We've got some plankton at the bottom. We've got the things, whatever it is, we're going up. We've got trophic level 1, 2, 3, 4, kind of 5. And we look at all of these interconnections of how each element is either food, it serves as food, or as a predator for everything else. And what we learn is, through studying ecosystems, is the more connections that are between the elements in the system, the stronger the system becomes. The more connections there are between the elements in the system, the stronger the system becomes. Look, so as the spider keeps adding more connections, going round and round and round and round. So think about that. That network, obviously that's a physical one made out of spider silk. It might be an information network. It might be a friends network. It might not physically exist. But so think about that. As if you're designing and building a system, and you want there to be many, many interconnections. Think about that. Relationships between the elements in the system, whether they are information connections, physical connections, or a trophic pyramid within an ecosystem. So that the number of these interconnections make the system itself more efficient. Mycelial patterns. It really fascinates me looking at this. I think I've showed this picture already, but I pulled apart 2 planks of wood. I was working with them, and this mycelium had explored the space between 2 bits of wood. And what we can see is it's got main arteries, like motorways, like main, clusters of, so that in some parts the mycelium can. So this fungal mycelium is like a tube. Think of it as like a porous tube, and inside is water and also enzymes. And when the mycelium finds something it's interested in, it will subdivide and create a node around it and start to drip out enzymes and start to eat or dissolve, interact with whatever it is that it's decided it's interested in. So there's a mixture of it wanting to send enzymes and water and channel it in 2 directions across the whole thing, across the whole ecosystem. And there's other areas where it wants to be really focused and create millions of surface area where perhaps it's doing something else, it's trying to dissolve something. So again, think how the shape of it's the same thing, it's the same organism, but the shape of it is altered intended function. So this might give us an idea about how to approach design in an abstract way. When we look into this picture, what can we infer from it? What is it that nature might be teaching us? A very strong pattern, because look, I've damaged it here, so I put my finger on it, and so instead of being able to go across like this, now it can reroute and use the other layers because it's also layered on top of each other. It's not 2-dimensional, it's 3-dimensional, and so it can still get from, if you like, from one part to another, but now it has to go by a different route, or it can regrow. Just think about that in an abstract way. So again, weaving is the same. It's a web effect, isn't it? It's the same pattern, and you can think about how the more connections we make, the stronger the element becomes. Okay, so there's a thought about that. So then we get to this. this is how nature is a favorite pattern. It's a scatter pattern, random pattern, a burst of seeds from something like a dandelion, the down floating on the air, and it's maybe not a very efficient way to send your seeds, but they're going to go everywhere. And if you produce long, yeah, it's a viable way of, and obviously, I'm going to explore the metaphor, random assembly, just blowing seeds blowing on the wind. But actually, then that wind's going to push them and they might get lodged into little cracks and crevices. Raindrops might follow them. Other materials like soil particles might also get lodged in the same place because they're being distributed, same forces mixed up together. And some of those, for sure, are going to find, good enough optimum conditions to enable them to grow and to carry on the cycle. So this might be a viable method of design, maybe not resource efficient, but you might add something that works very functionally. So we're going to consider all of these as possibilities, really. So this is a scatter pattern garden, an idea of mixing all the seeds together that we're going to grow, and then the surface of some carefully weeded ground, and then just watching them come up and thinning them out as they grow. We call this a polyculture, mixing many different seeds together, and it's a way of approaching garden design. And if you're interacting with it constantly, it can be an effective way also. And here we look, zooming into that, we can see different kinds of plants germinating. So some of those we've planted with the idea that then we're going to pick them almost straight away, like a green manure almost, or plants that are just going to eat a little bit of green leaf. Some of these we might then allow to develop and become fully mature plants. And we can do that slowly. But the fun part of this garden design is even as we're weeding it, because we deliberately put all the seeds there, we can just eat those weeds because we know we put them there for that purpose. So great if you're seed saving, if you have many seeds, it's a really interesting way to try to approach growing. And this also could be done for non-productive, non-food crops as well, for rewilding. Anyway, and then there's the wave. Think about clouds and water flows and the sea and the lake water and the patterns that we see in that, and water as a flow and waves, something flowing, again, weaving ideas around seeing patterning in different forms, the ripples on the surface of water. Electricity, energy is a wave, comes as a wave. It's interesting. Think about how a wave of water can push something along in front of it, and then think about how a wave of energy or sound might travel. Your heartbeat is a wave. Yeah, and then we see these wave patterns, we see scatter patterns, we see web patterns everywhere we look. These net type patterns. We see spirals everywhere we look. We see lobes everywhere we look, and one of our key pattern archetypes is this branching tree-like pattern, and nature uses it again and again and again. Clearly performs a very powerful and effective function. So these are pattern ideas we can bring into design. We use these things to inspire us and to see ways of arranging things that make them strong and durable and functional. And so we have this as sort of this pattern language to draw from. Okay, and then the last few slides are just again encouraging to see how in pure geometry the 5s and 6s give us a sphere. So we were seeing that then variations of that on the eyes of flies and the skins of lizards. This is actually hot igneous rock cooling down slowly and forming into hexagons. These are snowflakes looking at under the microscope. And interesting thing, every snowflake has 6 sides, 6 points. See the same pattern language, but every snowflake is unique. So that's back to that tree. It's really, really interesting, isn't it? So just think about that. Every single snowflake, if you capture it and look at it under a slide, is different. But they've all got the same, they're all generated by the same mathematics. So we always get a 6-sided crystal. It's what we mean. So we're seeing the patterns, and then from the patterns come the detail. But you have to see the pattern first. It's interesting to think about the patterning of plants and that whether their leaves come in pairs or opposites or 3s or 5s. These are geodesic domes, so these are structures using the same mathematics that we saw in the eyes of flies. And then this is actually the British Museum in London, and they're using variations of the 5s and 6s. We've got lots of 3s and different shapes, but we've got a curved building joined onto a square building. You can see how we can make very, very interesting shapes by understanding these basic principles and then playing around with them. This is a sea defense built out of cement shapes, but what shape are they? They're hexagons, because we want to make a wall that's a flat surface where each element is touching all of the other elements. So each one of these is touching another 1, 2, 3, 4, 5, 6 other stone blocks. That makes it really, really strong. So these things are pleasing to the eye, bring it into aesthetics for fun, for creativity, for sport, but also is that same hexagon shape gives us a chicken wire. It gives us, again, something that's strong and uses the minimum amount of materials to perform the function of creating something that can carry on a single plane. Remember, the hexagons gives us a single plane. And there's a tree which has been trained to optimize its shape as well. So, if we think about going back to our mycelium pattern and to think about how this distributed pattern is much, much stronger than this one. So if the one on the left, think of it like a caterpillar, think of something like that. So it's got a backbone. So if there's a break between these squares, if you like the principal elements, the whole thing fails. Whereas in a distributed system, if one of these squares was to fail, then there's another route. If this one was to disappear, this one can still go round this way. So think mycelium, our fungal hyphae are channeling information. They're sending water one way, enzymes, and where they find something that feels like food, that triggers it to subdivide, then absorbs what it's digested, and then uses that to distribute it around the network to reinforce the network. So really, it is like information. And we're coming to realize that in many ways, fungi they represent a kind of intelligence, because they are literally mapping, exploring every aspect of their environment, and where they find something interesting, they add lots and lots of detail, they nourish it, and then they carry on. They nourish from it and they carry on. This is really, really interesting. So we take this simple idea and we put it in a 3D environment, and suddenly now we can understand what might be going on in the fungi. And we've got our sort of super highway, the fast lane, to get from across the system from top to bottom. But we've also got millions of other ways to cross and get through this environment. So if there's a damage or a break, it can go in a different way. The information, the nourishment, the enzymes, whatever it is, can go in and find an alternative route. So, hey, isn't this super interesting? This is what resilience looks like. We've got mixture of multiple centers that are all connected in lots of different ways. This is what a permaculture network should look like. This might be a local group. These might be individuals. If we've got all the local groups sort of lined up, and then there's some, I don't know if that's a good analogy or not, but a distributed system. This is like a big power station that generates all the electricity and then sends it to all the homes. If the power station breaks, no one has any power. This is like a power system where you've got solar panels dotted on everyone's house and they're all joined together. So if one of them fails, the other one can kick in. This is a pattern of resilience. This is a pattern of resilience. This is what we're trying to learn from. We think about that in a three-dimensional way. And then this is kind of how our designs need to function. So again, I hope this isn't too abstract. I put this last picture in. This is some wood chip, so just wood residues. And I was gardening one day. I was using it as a mulch. It was a sunny day. I looked and I thought, gosh, these wood chips are all stuck together in a clump. I could hardly pull them apart. And I realized it's because they were all held together with mycelium. So look, this almost looks solid, but it's a complex web of different strands. And look what's happening. It's dripping out this enzyme, and you can see the wood is dissolving. And it's becoming like a liquid, and then the mycelium then is absorbing it back into it again. So it's slowly eating its environment, dissolving it, and it's doing it by creating lots and lots of surface area so it can create these interactions. So it's using this sort of mushy, sort of spongy web matrix to create surface area and strength. And this is what we have to learn from. Okay, there's some opening thoughts on patterns and sort of generic patterns. Any questions or feedback or thoughts from anyone? So we talked about wanting to spot patterns and understanding that they have a kind of, each one serves a function. Thank you, Caroline. To thinking about what the underlying function of each one of those patterns was. Strength, resilience, surface area, access, distribution. Yeah. Many things. Okay, I'll carry on a bit. We are an hour and 10 minutes in, so we'll do another 20 or so minutes. If no one's got anything to say. Okay, I'm going to do a recap. going back to the beginning of Bill Mollison's book of the Permaculture Designer's Manual, and but just focusing on the design bits. And I'll try and take about 20 minutes, 15, 20 minutes on this, and then we'll have a short break. So things change. Things are constantly changing. Nature never stands still. Part of permaculture seems to be to see those changes, see the patterns behind those changes, and to kind of move in relation to that. And we started again with some sort of patterns, observations set by Bill Mollison. He talks about working with nature rather than against it, to assist rather than impede natural developments. He said, the problem is the solution. Everything works both ways. Problem, solution, there's a relationship. Make the least change for the maximum possible effect. So we just saw in some of those patterns was the minimum material to create the maximum function. This is how permaculture works, and that's how, if you like, we're learning from nature. The yield of the system is theoretically unlimited. Think from bare rock to rainforest, and everything gardens. Everything in some way is modifying the environment around it through its own actions. So Bill also gave us these patterns. He told us we're moving away from this contemporary and predominantly Western idea of monocultures, of relying on doing one thing on a big scale and relying heavily on it. We're more interested in diversification, more conservation, maybe moving towards permaculture where a lot of what's going on in our land is just foraged systems. We're just actually letting nature do its own thing, and we've designed it enough so that there's enough within that for us to meet our needs, for our grazing animals to meet their needs. These are our design objectives. Can we create a system that just runs automatically on itself? Is that even possible? This looks at inputs and outputs in between those three systems. And what he's saying is there's an awful lot of money and oil that go into the agriculture, whereas in permaculture, it runs on sunlight and there's no waste. So concepts and themes in design. This is how, going back to the beginning of the PDC, Bill wanted us to start thinking in terms of how are we going to use this knowledge? How are we going to use the insights that we have made to create change in the world? A way in which is good for us, good for our community, and good for the natural world. We were given the idea of a design science revolution. So not a revolution of war and of attrition, of aggression, but a revolution of thinking and ideas and creativity. That's the only way that we will do this. Are you seeing this? Sorry. Gerald.
Yes, yes, Dave.
You can see that, okay. Just checking.
Yes.
Okay.
But are you playing something?
No.
Okay, I think someone
is unmuted who perhaps should be muted.
Oh, okay.
Okay, Kafka. No problem. Okay. Share screen. Okay, this was we're also reminded, man did not weave the web of life. He is merely a strand in it. Whatever he does to the web, he does to himself. To harm the earth is to heap contempt upon the creator. Contaminate your own bed and you will one day suffocate in your own waste. So we've got these ethics, but we've got them for a reason, and we're trying to allow nature to teach us. we're trying to follow nature so that we can be successful, be abundant. We're also, this is an interesting idea to come back to as well, is a policy of responsibility to relinquish power. So let's say you start a garden and you start planting plants, you're putting yourself in control, you're making you responsible. So imagine that if your garden naturalizes and becomes a food forest that's propagating itself, you've relinquished power. You've given something a life of its own. So good ideas and good design initiatives can go on and have a life of their own. So let's think about that. Your role as a successful designer. So the role of successful design is to create a self-managed system, a system that runs itself, just like the rainforest, just like a natural system. That's the potential that we're aiming for. Okay, so we're reminded that ecosystems are dynamic, that the elements just randomly fit themselves together, that they evolve in complexity and interconnections. They contain niches and there's specific little habitats. And there's a relationship between each trophic level, between the producers, seeing trophic levels between the plants, primary, the primary trophic level, the first trophic level, which is always going to be plants photosynthesizing. It's insects, frogs, fish, people, all feeding along that food chain, or in fact, linked together through a complex food web. Another consideration that we are encouraged to think about in permaculture design is to realize that water is everything. If you haven't got any, you can't do anything, and if you've got too much, things get washed away. So we need to observe our landscape and at the broadest possible perspective, and think about how we can slow down the flow of water, how we can make it move from where it goes from the source to the sink in a straight line. How do we make it do a long, complicated journey? Where can we trap and hold water in our landscape? How can we stop it from just running out? And also, we're thinking about climate resilience. We want to be able to hold as much water as we can, and we need to have maybe a sense of what's going to happen when we get too much, if we get a downpour as well. So these are patterns we need to think about. We need to have in the back of our head as we think about design. Okay, so permaculture design is a system of assembling conceptual, material, and strategic components in a pattern which functions to benefit life in all its forms. It seeks to provide a sustainable and secure place for living things on Earth. So we're trying to design for life in all of its forms, we're reminded. And it also says every component of your design should function in many ways. So trees that can also be windbreaks, trees that can provides fruit for you and fodder for someone else, for your animals. Every essential function should be supported by many components. A flexible and conceptual design can accept progressive contributions from any direction and be modified in the light of experience. Wow, that's quite a big sentence. So a good design, you can keep adding to it and allow it to slowly grow. And as it slowly grows and you make changes, it becomes stronger and you learn and you become a better designer. So that's what we mean by a flexible conceptual design which will accept progressive contributions bit by bit, small and steady. Small and steady wins the race. Design is a continuous process guided by the feedback of its own evolution. So that was our Sadimet model that goes from the survey, analysis, design, implementation and maintenance, evaluation and tweaking, back into survey again. It's a continuous process. Okay, these are the foundational ideas. And then the next second phase of the design is based around analysis and asking key questions. When we talk about elements that perform multiple functions, understand that actually everything has inputs, outputs, relationships, behaviors, activities that it does. And if we can understand that as a whole and as a holistic way, we can then find ways to integrate those elements into the system so that they can take care of themselves much more, and they can meet their own needs from within the system, and we can cluster things together to create an overall better impact. So this is a lovely picture from the designer's manual, imagining a sort of simplified farm moving over to something that's much more complex. We've got more soil attrapment. We've got a diversity of crops. We've got fodder trees in with the cows now. We've thought about integrating things together. There we're seeing again a schematic of the same transformation. So we're moving from simplicity to complexity, and you can imagine that how moving this farm, changing to looking at something like this, there would be many small steps along the way. And as designers, we're going to ask you to think about, imagine, understand what those small steps might be. We're going to design through observation. We're going to make childlike, non-selective, fundamental questioning. We can think about on themes: water, energy, food, access. What information or data do we need? And as we begin to unfold this, we can also gain from our own experience. So we're asking you to think about this design process and to use observational tools to look at, to interrogate your site, to learn from it, to act, anyway, it's all in here for you to download. I'm just recapping this to realize that we want to bring all of these ideas with us into our design phase, not just elements of it. We're trying to think about it all. We're trying to understand how natural systems work and make that work for us. So we might be thinking about a sequence of crops or social investment. How do we involve people? How do we create community benefits? And many other things. Look, so anyway, we've talked about zones and sectors. We've touched on gradients already, and guilds and succession. Hopefully these terms now are becoming a bit more meaningful for you, and you're more comfortable with using them and what we mean by that. By all means, ask questions should you want to. So it is now 6 p.m. UK time. So I think that's about our halfway point. And I'm gonna just pause there. And I'm gonna hand it over to you, Gerald. Any thoughts, please, or any questions from anyone else? Thank you.
Yes, Steve. Thanks for the session. It's always, interesting. Sorry, I got a midway kind of engagement, like crisis, so I had to sort it out. But then it's always interesting. This is one of the points that I wouldn't love to miss. This is where now everything starts to tie in. It's like the apex where you're having now to do the linkages. Think about how the initial bits, the ethics, the principles, the first 6 principles, and then bits of the second batch of the principles are tying into now placement. Because from experience and from what I know, however much you could be as knowledgeable or you could be as efficient as possible, but if the system is not, if the placement is not, then a lot of efficiency is going to be lost on the way. It is going to somehow sort of derail you. So it's really, this is a very interesting phase. And then it's also inviting us to think as broadly as possible, but rather in a more simplified way, especially if you're taking the route of a trainer or project lead who is going to be taking a lead on this, on either training or implementation or working with communities. Thanks, Steve.
Thank you, Gerald. Okay, guys, let's have, should we, 10 minutes, too much?
Let's have 10 minutes, but then we can leave it open in case anyone has a question or
Sure.
contribution. Feel free to throw it in. I'll be in the background and Steve will also be around.
Okay, I'm just going to make myself a tea and I'll be right back.
Yeah, sure. All right, see you in 10 minutes. That will be exactly 10 minutes past the hour because it's now 6 exactly where we are anyway. Hi, Simon. Hi, Simon. We're currently in a break.
Yes.
Yes, I see you just rejoined. Were you on and probably you lost connection?
Yeah. No. It was network problem.
Okay.
Hello.
Okay. I guess you haven't missed a lot. Maybe you could tell me where you could have opted out, or maybe when Steve is back, he can do a quick recap. Okay. Otherwise, you're welcome to make yourself a cup of tea, and then quickly we catch up. We carry on in about that's in about 8 minutes. Okay, I've placed something for members to think about. Quite interesting.
What is that exactly? It is on chat, eh?
Yeah, on chat. Can anyone tell what that is?
Let me check. Something media is but
Okay, anyway, I would tell Steve to download it, then he can share it, and I can tell you the story behind that.
Okay. Whilst people are just coming back, a reminder. Oh, hello, Simon. Welcome to see you. Watch out for Tess Fahu, and he's trying to join us as well. So I'm just hearing back from a couple of other people. So Paul Ogola is talking about, they have a group of 40 who are following this course they're in Homa Bay in Kenya. They went on a field trip this week, and they've been to a community farm where they have a biogas plant and they're growing fodder for their animals. And Paul's going to post some pictures of that, so that will be interesting. And we've heard from Tess Fahun in Ethiopia. He's just been on a syntropic agroforestry course, so modeling from patterns in nature for kind of food forest design. So it'd be very interesting to have some input from him on that.
Steve?
Yeah.
Yeah, so, by the way, Simon, I think, needed a bit of a recap. He dropped out along the way, but then
Okay.
I've also shared something interesting. It was at a farm in Buama.
Oh, yeah.
And a pattern in nature, or, a case of nature showing us form following function. Thus, are you able to share that? Let me see if I can share from my end. Or maybe you can share it from your end. Then I can let the team can brief them quickly. Let me see. Yes. Is anyone able to relate about that? Or can anyone tell what that could be? Those are nests of one of those noisy birds, the weaver birds. But the interesting bit is how they're constructing their nests at the end or at the tips of that palm plant or the palm branches. That is fitting, a form or to a function. Usually this is a safety like trick for them, constructing at the end to avoid being attacked by predators, which predators are usually heavier than themselves, or probably when they are away to fend for the young ones. If it's a stable kind of structure, then the predator could come and just pick up the young ones or the little ones and take off with them, or even the eggs. But since this is at the edge or at the end, you find by default, as a predator tries to come to pick these up, this will fold, or it will create kind of a shock that is about to break, and obviously the predator will have to fly off or to run off. So this is nature teaching us or showing us how to fit the form to function, or to design to either solve a specific problem or to provide a solution. Thanks, Steve. Back to you.
That's great. And that's a great way that you've used your own observation to illustrate that point. And you can also imagine that for the bird, maybe it was like a scatter pattern approach. They tried building their nests everywhere, and they kept getting eaten unless they were at the end, and they eventually learned that lesson. Who knows? But you can see how trial and error, we learn, we apply what we learn, and the system improves. That's what we're teaching. Okay, so we just had a bit of a recap looking through Mollison's principles, and we didn't quite get to the end, and I'm going to we will come back to that again, because it's what everything else is built on, and there's just different ways to describe the same kind of things. I'm going to show you. I like to show this slideshow within the PDC, and it's about design, and it's about abstracting a bit about design. So again, this is the second half of what this course is about. It's about how do we design, how do we create change in the world. And I love this quote: design is a process of making dreams come true. What's your dream? What's the objective of your design? What is it you're trying to achieve? And the more that we can define that, and the more that we can visualize that, the more likely we are to be able to work towards and achieving that. And look also how the thing that we're designing might be really complex. It might have lots of different aspects to it. So we're going to have to think through it sequentially. So sometimes we might be problem solving in one area of the design, and at another time we're thinking about the whole thing. Well, look, here's someone who's done a permaculture design on their land, and this is the top. These are the contours that are showing you the contour as a line on a map drawing places of equal height. So it's 100 meters at the top and it's 80 meters at the bottom. So we've got a 20-meter fall coming down, and we can see the shape of that. We can see, look, there's water crossing the land, and there's an element of the design here where they put in a series of little catchment dams. And that might be because they want to slow down the movement of water and hold water in the landscape, high in the landscape for as long as they can, to have the chance of other yields. So we're seeing evidence of zoning. Look, here's our way in. Here's the access track. And that's going to be that could be a key limiting factor in your design, is maybe you haven't got many choices where you could get your access in. But once that's decided, that's then going to inform you what comes next. So the homestead needs to be close to the access, because we're going to be delivering them building materials there. And then when you live there, you might be traveling in and out or having other deliveries. So there's our zone 1. So we know where the zone, and once we've located the house, there might be a lot of considerations where to put it, of course. But once we've thought about that, where it is within the land, where it is, how accessible it is, how sunny it is, how windy it is, we can then begin to place elements around the house that support the house function, the zone 2 function. And look, we've got some raised beds, we've got a nice little mandala-y looking garden, and different elements, things around the house there. So there's a zone 1 and zone 2 kind of things going on. This is over here, bush regeneration area. So right on the periphery, zone 5. We're just letting this go wild. Look, all of this red stuff here is a zone 5. Commercial production of trees. So this is the main part of the farm, look, and all of that, that's the zone 3. That's the bit where they're doing their most intensive work. And then we've also got grapevines there on the sunny slope. And we've got cold climate orchard and stone fruit. So look, we've put the cold climate plants at the bottom because cold air is heavier and it'll slump down and it'll be a bit cooler down there at night time. So we're looking at somebody's approximate design, and we're just appreciating that they've thought about zones, sectors, placement within that. Okay, so this was their process of making their dreams come true. And what's going to be yours? Okay, there's actually a lovely talk on YouTube by Janine Benyus, in which she talks about biomimicry, copying life, copying nature. And in her, she's not a permaculture person per se, but she's doing exactly the same as what we're doing, learning from nature. And she sort of summarizes the principles of biomimicry as 9 things. Nature runs on sunlight. Nature uses only the energy it needs. Nature fits form to function. In other words, doesn't matter what it looks like, does it do the job? So I've got a picture of a moth with a long proboscis. It might look pretty funny, but it fulfills the function. Nature recycles everything, produce no waste. Nature rewards cooperation. That's integrate rather than segregate. Nature banks on diversity. Nature demands local expertise. Demands. So that's the detail, and we need to get things in the right place. Nature curbs excesses from within. Nature taps the power of limits. All of these actually relate very strongly to our 12 design principles, but it's just interesting to hear them articulated in a different way.
Steve, are you sharing?
Oh, sorry, am I not?
No, you're not. So,
Sorry. Sorry about that, people. I hope you can see that properly now.
yes.
Yeah. Okay. We haven't really. Sorry. I was looking at being this image, which you didn't see. Saying it was, this is the top of the land, this is the bottom. Here's the access and the home, and then the elements that support the home clustered around that. And then as we move further away, we have less into from zone 3, zone 4, zone 5. And look how when we look at this design overview, there's lots of different elements there, and they're carefully placed to support the function, water, reducing erosion, creating wind shelter, allowing for access, creating yields, exploring the different microclimates of the space, understanding the difference between the top and the bottom. Look, we've got a shelter belt planting all along here to keep the cold winds off. How within our design, we're designing to fulfill a range of different functions. We've created the gardens to support the house. We've got the wider ecosystem for farming. We've got the water treatment, and so on and so forth. It's this process of making our own dreams come true. Dreams that run on sunlight, only use the nature that is needed, that fits forms to function, recycles everything, rewards cooperation, banks on diversity, speaks of local expertise, and is self-regulating and taps the power of limits. That's where we're going. Here we've got another set of ideas. Life creates the conditions conducive to life. Adapt to changing conditions. Be locally attuned and responsible. Use life-friendly chemistry. Be resource efficient. Integrate development with growth. Evolve to. Okay, same ideas, but just being expressed using different words from different sources. So, a friend of mine put this slideshow together quite a few years ago to help you think about design. And he was a guitar builder. He was someone who made musical instruments, and so it's about musical instruments. And let's just say this is that we can use the thinking of permaculture design to design anything. It doesn't have to be a garden or a community. So we can think about it in an abstract way a little bit as well, and I think that's a fun thing to do here. So take a big deep breath. We want to design. We want to create change in the world. We want to design to meet our needs. needs. So how we approach design and what we do, what we aim to achieve with it, and the steps that we might take will be really informed by the function, the application. What's our primary objective? There might be lots of objectives, but we need to make sure filling those primary applications. And so, yeah, he called it application. We quite often say function, to design to fulfill function. And then also is, what materials have we got? And again, let's look around, let's see what's locally available, what's abundant, what's cheap, what's affordable, what's strong, what can we grow? And whatever design we come up with is going to be a two-way interaction of those things. So again, back to the idea when I showed you the dragon tree and talked about every design is going to be unique because it's going to be an interaction between the design process, the designer, the decisions that are made, the functions we're trying to achieve that we have to achieve them out of. But it needs to fulfill the function. And if it's done that, it will work and it'll go ahead and you can build on it. So, thoughts on musical instruments. How perhaps this is a piece of bone from a bird. It's about 50,000 years old, and clearly it's been worked. It's got some holes in it. And the proposition is, imagine this: you're sat around the fire, eating sucking the marrow out of your whatever it is you're eating, this animal bone, and as you suck it, it goes, you get a little noise, and you go, oh, how exciting, how fun. And then you, as a designer, you've got this material and you identify the applications. I can make a noise with it. Oh, I can play with that. So now I can fine tune it. And from one noise, I can put a series of holes in it. And so I've made a flute. I can make a series of noises. I can compose a tune. So see how you as a designer might have some basic materials and a sense of application. And by experimentation, playing with it, come up with something. You might come up with something new. You might come up with something significantly better than what what might happen is the realm of possibilities might open up. You see more chances. So imagine this: a bent stick with a bit of animal gut on it, and it's tensed because the stick is bent. So if you touch it with your thumb, it's going to go doing. Nice. That bow might have been for hunting, it might have been for starting fires, it might have just been created for making the noise. Who knows? But again, think about how creativity and experimentation might create something that doesn't exist before. The designer coming up with an application and interacting with materials. So in this case, we've got a stick, we've got a bit of an animal gut, we've noticed that it goes doing, constructed that thing, this little bow, and the next observation is, if we put it on the edge of our mouth and use our mouth, our buccal cavity, our mouth cavity as a sound echoing, we can make a much more, and I can maybe open and close my mouth, I can make a range of different sounds. And you can imagine how people would just playing with materials, playing around, oh, isn't that funny, the sound it makes, quickly becomes a powerful tool of communication. So this is a traditional Brazilian instrument, and you can see now how a coconut shell performs the function of the mouth cavity to amplify the noise, the badoing noise. Okay, so now we can create musical form based on amplification of the vibration of a wire. This could be or of a piece of animal gut. So this could go right back in time to as far as you could possibly imagine. You might innovate with that design. Here we might have this I don't know. It looks like it's worked. It's not just an amplifier, it's got a skin on it, so now that resonates. Look, we can have strings, more than one string, and those strings could be of different lengths. Now we've got a doing, doing, doing. We've got a range of sounds. We have new possibilities. So all this is design. This is your permaculture garden evolving. Start off with a very simple notion, very simple materials, but quickly you can innovate. You can add things. You can begin to look. You can start to layer it, build more complexity into what you're doing, and the next thing you know, here we are. A fantastic inlaid with ivory and ebony guitar from the 17th century. Probably cost a fortune, a statement of human artistry, maybe created for more than, you can see this is like a folk instrument, that this is for playing around the fire, for people to come. This is more a statement of ostentation and and also showing off of artistry. But that creates a different kind of thing, but the form fulfills the function. So if all we're interested in is making it, doesn't need to be any more complex than that. On we go. Think about guitars, think about violins, think about musicianship and how important that is, and that how, especially in the sort of European era, that instruments became these precision things that actually became very expensive, and you'd have to go and study to learn how to use it, and you'd have to be reasonably wealthy to have such a thing. And so they occupied a very different place in society as something like this. They're still really serving the same function. And then sometime after the war, or even in between the wars, I think something really amazing happened, and that is, with the industrial process, they learned how to mass produce guitars, and suddenly musical instruments were available to people who never had them before, to people who'd only ever had the homespun equivalent of something like this, a string that goes kadoing, or possibly, slightly more complex. And then through industrial process, suddenly, this is Charlie Christian, who's a jazz innovator and one of the very first people to popularize the guitar. Jimi Hendrix, just later, could have become one of the most kind of ultimate musicians. But the key underlining is actually the guitar makers managed to create a tool which does the job really well, effectively, as good as that amazing Martin guitar with all of the ingrain on it, but it could be produced in a factory cheaply. So, and what happens is, if you put a tool as powerful as a Fender Stratocaster, which is what this guitar is, you put out and make it available to people, and then let them innovate, they come up with so much diversity. They come up, look, it's made from simple components. It's not out of reach. You can make very, very beautiful instruments out of it. But then that if you like, that can be interpreted and expressed in many different ways, in crazy, fun, different shapes. But also, what happened was putting these instruments in the hands of lots and lots of people in the 1950s, 1960s, 1970s created whole new musical form that hadn't existed before. And suddenly a whole new kind of vistas of possibility that no one had ever thought about. So this guy here is just an interesting story. This is just to think about design a tiny little bit. His name is Tony Iommi, and he comes from Birmingham. And in Birmingham, he used to do a lot of heavy industry. When he was a young man working in a factory, he lost the tips of his fingers with a big power hammer, slammed down on his hand. And later on he became a musician. So he had to work around the fact that he didn't have fingertips. They came up with the idea at the time I think at the time it was a very popular horror film. And they're watching people queuing up outside the cinema to watch a horror film, something that would scare you. And they were going to a rehearsal, and they said to each other, what would be the musical equivalent of a whole. So rather than music that's happy, it makes you joyous, but something that's like scary and dark and thunderous. And they went away and they invented heavy metal, a whole new form of music, which is now has many thousands of sub and different bands. But that idea created a whole new kind of universe of possibilities. So your design can do that. Your design can open up potentials that before you couldn't have even dreamt that were there. This is another, to carry on the guitar analogy, this is a guy called Django Reinhardt. And he grew up in Camargue, Gypsy, Romany tradition, living in a caravan and moving around. And as a baby, there was a fire in his caravan, and he lost 2 fingers and half a thumb. So he only has half a hand. And he later became a sensational guitar player, but he had to create his own style of playing that suited someone that only has 2.5 fingers, because he couldn't have everybody else. So he created a new style within the limitations of what he had. So think about that. That design has if you design 2 limiting factors, I've only got 2.5 fingers, I'm not going to be doing certain kinds of playing, but I can do intricate picking, which is what Django Reinhardt did in a really rhythmic way. So he created his own style of playing that now other people with 5 fingers try to emulate and can't. So we design to limitations, design to fulfill functions, and we realize you just use what you have. Okay, and you get creative. You can make guitars look like anything. You can do all sorts of crazy things with them, but do they still play music? Can you, afford to buy it? Can you afford to fix it? These are key ideas. Okay, there's some thoughts about design from someone who was a guitar designer. So I hope that was interesting. I'm going to go through the sort of permaculture design models a bit further. Oh, yeah, okay. I hear you, Nicholas, so you will get it later. Yeah, okay, so this is. I think when I put this, I wrote this slideshow a long time ago. And I think what I wanted through it was there's plenty of ways to approach this. But I want you to think about it as a process and as quite a creative process, but you can approach it in different ways. We've given you this Sadiemet model so that you've got step by step you go through. But I'm going to kind of show you how we got to that and where that comes from. And again, more thoughts about how to think about design. So in this, we're going to look at this the scientific process, and then 2 or 3 other examples. So in science, we say we make some observations, and then we ask some fundamental questions. Why is that like that? We might have an idea, so we construct a test to find out if hypothesis, our idea, if it is true or if it's false. So we run a test, we look at the results and draw conclusions from those results. That's the methodology, if you like, that the whole modern world is built on, the scientific process. But of course it has a feedback loop in it, because it's got to be a bit smarter than that. And so let's say we have our question, we do some research, we construct our hypothesis, we come up with a test our hypothesis, and we look at the results and draw conclusions. If it's true, we might go ahead and report those results, write a paper, construct another test, or if it didn't work, we might, or only partially work. That's the result, so we've learned from that, but then we might fine-tune our test, fine-tune our hypothesis, and go around the process again and keep trying until we get the right result. So Gerald's birds might try putting their nests anywhere along that frond, but the ones that do it on the end learn that that's the safe place to do it. That reinforces that behavior. That's how we learn. That's how it works. So through design, we test out ideas, and as we learn, we can then implement them with increasing confidence. So this is also why we encourage you to start small and to build on your successes. That's a good way to use your energy. That's a scientific method. So one of the biggest selling permaculture books, especially in the US, is written by a guy called Toby Hemingway, and he's a very good author and a very good communicator. Sadly, passed away now. And in his book, he talks about it always starts with observation. It always starts with you looking at the problem. We talked to you about you got to interrogate the client, you're going to interrogate the site, you're going to interrogate any kind of historical data there might be, and you're going to look for leaks. That's your observation plan. From that, you can begin visioning, having ideas. Let's try this, let's try that. We might start off by thinking that in a vague idea, in a conceptual, big picture, broad brush kind of way, and then slowly focus down to a schematic design, something a bit more detailed, and which is built on what we've thought, the thinking we've done before. And I showed you how we did that in our garden in Newtown, and our garden project that created the Cultivate Horticulture Centre. So then we were going to go into developing our design ideas, and we're going to then begin to implement it. Okay, so we get this process from science, from Toby Hemingway, and this is a book called The Universal Traveler. I just picked this slide up from someone I haven't read it, but I like the idea from this, and it says, accept responsibility. Who's going to make this change? I am. We are. We're going to take the lead in this. Okay. We're going to analyze, we're going to do some thinking, observe. We're going to define the problem, generate ideas, choose which ones of those we like, and then begin to implement them. And we can generate lots of ideas, we'll be really creative, and then we can spend some time really sifting through them and finding out maybe the most important ones, think about which ones we want to do first, and then we can then begin to implement and evaluate. As we implement, is it working? Is it doing what we wanted to do? Are there any unintended consequences? So this is a nice, again, notice how these are very, very similar. I'm just trying to synthesize these together. This is a 4-part model of called Patterns of Creativity, a synthesis model. So, and again, let's think about creativity. Let's think about design, how we make our dreams come true. Let's say it has these 4 stages to it. That we start off with, here you are living with it in your house, looking at your land, looking at the problem you want to solve, experiencing it. So the first stage of your design is going to be preparation. Okay, and that preparation is going to be the observation. Interrogate the land, interrogate the client, understand the history, look for the leaks, understand the seasons, the changes, the materials that might be available. All of those things that we touched on last week is part of your preparation. Okay, so we then feed all of that observation into the next stage, which is the analysis. So what did our observations mean? Can we make some sense of that? And as we enter stage 2, imagination, can we start generating ideas based on our analysis, based on what it's telling us? Well, the climate's like this, the resources are like that, the needs are this, these are the things that we, the available materials that we have. We're now going to generate ideas, and we're going to then start sifting through those ideas, harvesting them, picking out the ones that look the most important. So we've gone from experiencing it to thinking about it analytically, and then generating ideas, picking out the best ones, fine-tuning them, and then look at these 4 stages: preparation, imagination, development, action. We do the action, and then we observe to see how it worked. Then we carry on, and that understanding that we know what's good, what's not, what do we need to keep changing. We come up with solutions. We fine-tune those solutions. We apply them. Are they doing what we want them to do? Ongoing. So again, this ongoing process of design being open-ended, ongoing, inclusive, informed by feedback, informed by your experience of the design. And you keep asking the fundamental question, well, is it doing the function that we intended? Are we getting the outputs that we wanted? And there's our Salimat drawing. So that's the stat, if you like, is trying to. I did an easier to look at PowerPoint, a PDF of this last week. So, we try to show how you're incorporating all of these ideas in a step-by-step process that actually is continual and moves from experiencing the current situation, making observations, analyzing those things, and then coming up with ideas to address the issues that you're experiencing. So there we are. We'll go back and just touch on our patterns to detail. This is where we are. We are using now our permaculture thinking to understand or look at the energies that there might be on a piece of land that we're interested in. Can we think about the sun and the shade, the slope, how water is going to move that land through that land? Where does the wind come from? Other issues with noise or light, other particularly beautiful views that we want, other things we might want to block out. How will wildlife cross the land, or come to that? How will the neighbouring kids cross the land? Do you need to be concerned about fire? What happens if there's a bushfire? Do we need to design for that? If we were to look at, say, our home, well, if there's our zone 1, and we're trying to understand the wild energies around it, let's just understand that if there was a bushfire, warm air rises. So what happens when there's a fire is it goes uphill. Okay? And it's going to be driven by what? The wind. So if we understand how the winds work and the slope works, we might be able to think a bit more about fire exposure, and we might want to bring that consideration into our design. If we know where the winds are, we might want to design to shelter the property or to so we get a sense of where we're going to when we come to the design phase, have a sense of where we're going to place our elements so that they fulfill multiple functions. We talked about the zones. So, and again, thinking about how on this picture here, we're seeing sort of zones and sectors working together. There's our settlement in zone 1 in the middle, and our more intensive activities in the zone 2, main crops in zone 3, and then the periphery of the farm, the edges and the hedges out on zone 4, and then zone 4 connects through to zone 5, to the outside, to the wilderness. And we might want to invite some of that wilderness actually down into the heart of our land. That might be a wildlife corridor, or some forestry, or hedges. It might be a river. Might be lots of different ways that that wildlife might track and cross your land. Can we design for it? Can we design so that animals, if wild animals do come onto our land, they're deflected and stay out in the zone 4 and maybe don't come into the zone 2 and eat our crops? If we can spot those patterns, we might be able to bring that into our design. And again, taking that overview look and think about what's going to happen when it rains. Where's that water going to go? What happens if we get a lot? What happens if we don't get enough? Understanding the shape and the size of the land is very, very important. So yeah, water, slope, pathways, and then the key elements like buildings. We need to get these things right first. And the shape of the land and where there is water will also influences where we can locate key elements and also where the access and pathways are. So we're also designing with a sense of priority. We're always going to need access. We're going to be key. We can't do anything without water, and we're never on flat land, or very rarely on totally flat land. So these are going to be considerations that shape the whole design from the beginning. It's thinking about the sun and sun angles, designing to the detail of the climate that we're in, asking ourselves whether we want thermal gain or thermal loss in our buildings, and being aware of where we might place a building within the landscape so that it either has a solar gain or solar loss. We can model how the sun moves around if we find it hard to visualize. There are apps now you can use on your phone which tell you. In urban settings, there might be intrusive noise and lights from neighbors or from other enterprises. We might plant strategically for privacy, for suppressing noise, for keeping if we understand how wind flows around the house as well, then that's going to also inform us of where to locate elements so that they fulfill intended functions. If we're going to plant a windbreak, why not plant a windbreak that has other functions? It's a biomass yield. It's good for wildlife and nature. It also adds to privacy. So think about how we use design to address fulfilling functions. Now, I think this is a key consideration and one I like to repeat. Always remember that water runs downhill. So when we say water is a key consideration, we can also predict where it's going to go. And we can design for that. So if we are aware of the shape of the land and of the topography, we can model it or visualize that in a way, and then we can then build strategies. We can strategically arrange elements to slow down that passage of that water through the landscape. We can start our stock at the top, encourage the animals to move sideways rather than up and down, so that their hooves don't create gullies. We've restricted their movements. We've added swales to trap water and allow that to feed the trees, which are also going to stabilize the landscape. So we start with the rainy season up on the top of the hill, and as the season moves on, we bring the cattle or the animals down sequentially, because we can then follow the grazing and follow the water. So the last fields to graze will be, there'll still be some fresh green grass will be at the bottom. And again, we can observe these patterns and then follow them. We can reinforce them by strategically placing elements in the system to fulfill the overall design. We choose elements that fulfill multiple functions so that we get shade trees, help feed our animals, or maybe help build soil, or good for nesting birds, or fulfill a variety of other intended functions, have long-term timber value. That's called stacking functions. We have elements that perform multiple functions. A water catchment system that's fulfilling multiple functions. Channeling any surplus water, making sure it catches it and feeds it into the dam. We have a high-level dam, a mid-level dam, and then an outflow coming down the bottom here in this designed system. So when because water is always going to flow downhill, we can predict where it's going to go, and we can put systems in place to harvest it and control that flow. But if we get a heavy surplus, overflow of rain, which might happen, the dam needs somewhere to discharge. And the rule is we always want to discharge water along contours or as shallow as possible. And if it just overflows, we discharge always into vegetation, into vetiver hedges and contour plantings of trees. So that, again, think about how these elements that we've put in for our grazing system might also perform a function for our water catchment management system and reducing erosion, causing runoff and heavy rainfalls. Think of strategies to hold on to every bit of water, feed it into the system, and then make it travel as long a distance as possible, so that it can nourish the landscape, so that it can humidify soils and plants. That's our design consideration. We're always thinking about how water is going to move through the system. How do we slow it down? How do we stop erosion? If we can understand the shape of the land, we can predict where it's going to go, and we can then have systems in place to manage it, to harvest its energy, and to get the maximum benefit before we let it leave back down into the system, rejoin the system. If we're really clever, we can connect dams together. If we work on contour, we could make water flow slowly along a great distance and create interconnected systems. The only upper limit to what you can achieve is your own imagination. If we can get multiple uses from each resource before we let it go, the system itself becomes more productive. Thoughts about design. We're going through our Salimet process. We are also trying to maximize edges. There's more interactions at an edge. So where a pond meets the shore, you get a really interesting, unique set of conditions. It's not quite land, it's not quite water. Lots of creatures can get in and out and get the benefit of both sets of conditions. So let's say all of these ponds have the same surface area of water, but clearly this one has much more edge. There's much more opportunity for things to interact between the land and the water. And so therefore we might explore different shapes to fulfill different functions. This is like your palette of ideas that you can play with as when you come into your design thinking. So this is from the designer's manual. Here's a lobed pond following from this basic pattern idea. And it's not just, so to get a range of different conditions, it's also deeper in the middle. So I like this idea here that this is an imagined fish farm. So we have the tiny little fish fry in the shallow waters, which is the environment that suits them, the microclimate that they would favor. And then obviously get a bit bigger, they explore into deeper water, and then the fully adult fish here in the deepest bit in the middle. And that by having a lobed pond, maybe, and with look, carefully planted shelter trees, it's saying there, oh, winter winds are kept off by strategic planting. We've got, and this one lets the summer sun, summer winds come in. You know, they've thought about sectors. They've thought about the requirements of the elements within the system, and they've created a diversity of habitats just by exploring shape and depth. So think how we can be really creative in permaculture design. So in the same way as we can predict where water will go and where water will end up, we can also predict airflows. Warm air rises. And that's because cold air is heavier. So actually, it's the cold air sinks and pushes up the warm air. And if you have a large body of water, like the sea, like Lake Victoria, next to the land, what happens is as the sun rises in the morning and the temperature rises, the land heats up faster than the water. It's more responsive. So you get a convection current coming off the land and cold air sinking down over the water. So we're seeing the cool, damp air coming onto the land and warmer, dry air leaving it. And then in the evening time, the land cools down quicker and the water holds its temperature for longer. So now we're seeing warm, wet air rising off the lake and coming this way, and the cooler, drier air slumping down. So we're seeing a reverse of air pressure and the airflow being affected by the relative heating and cooling of two different bodies. That's something we can bring into design. We can think about whether we can predict where these airflows are going to go, and we can decide if we want to push cold air away, invite it in, and the same with hot air. We're seeing the patterns, and then we're zoning in on the detail. Remember when we talked about the heating and cooling of buildings, and we looked at termite mounds? This is the same ideas. So cold air is heavier, and we certainly have, if that cold air is less than zero, it forms frost, ice forms, and that will kill plants. And so something that we observe is you get hollows, you get places where cold air gets trapped and it becomes particularly cold there. And this can happen either behind or like a wall of things, or just reaching at the lower parts of a landscape. So making observations, we can understand the microclimates of a landscape, understand how cold air might cross it. So here, look, here's an example. Looking down a hill, we're in a field looking down the hill, and there's a hedge line, look, a line of trees and shrubs, and you can see the cold, damp air has trapped behind it, and it's sort of welled up, almost like water behind a dam. So that's a frost pocket, a cold air pocket. So you need to be aware, you need to think about things like that. You might want to change the shape of the landscape to reduce that effect. You might want to build your house down there in the cooler air, or you might want to come up here in the warmer air. All of these, from observing landscapes, help us understand, and then we can think about how to use these factors in design. Here's an orchard in a steep valley, and cold air at night time comes tumbling down from the mountain, and it might damage the trees, give them a frost, they might lose their blossom, might lose the fruits. But a simple construction, even just a fence, it just adds a little bit of wind resistance, slows down the flow of the air, so then the majority of that cold air actually is pushed off and travels around. It'll always take the path of least resistance. So in the same ways we can direct the flow of water, or we can direct the flow of cold air. We can direct the flow of wild animals. We can direct the flow of people by strategic placement of elements to fulfill a function. In this case, diverting the wind, but it might also fulfill other functions, like keeping wild animals out, or stop the children from stealing your fruits, whatever the reason might be. So this is a humid landscape we're looking at on a slope, and we've got 3 dams placed on this. So, and this is sort of an exploration of slope, altitude, and a few thoughts about how cold air and warm air might move across our landscape. We might have high meadow up at the top on the hilltops. So we might be able to take our animals up there in the spring. It talks about a ridge forest on this steep slope, more than 20 degrees, 18 degrees, greater than 18 degrees to be forested. And then we can cultivate further down. And we're also seeing how the falling of the cold night air coming down interacts with warm air rising, and careful placement of elements. This ridge point dam, this house, this food forest helps maintain and explore the local microclimate conditions, so that the cold air coming down the mountain doesn't just dump onto your house. And an exploration of the best places to live is just below this inflection point, where the landscape moves from being greater than 18 to less than 18 degrees. And then here we can start building swales and more detailed water catchment. And then, we've got a low dam at the bottom. And we're seeing again how warm and cold air mixes together. There's a lot in these pictures. Anyway, so we started off by thinking about the things that we can't change: the shape, the shape of the land, access, where the key elements like houses are going to be built. And then we can think about the other systems, food growing systems, our sort of water management systems, other shelter and built environment elements. Are we harvesting energy and energy trappement? And the production and use of the physical resources on the land, and how we're going to reuse anything that otherwise might be regarded as waste. So we need to build physical systems that sit in the landscape that address these issues. So here we again seeing a designed system, which is an assembly of elements to fulfill a set of functions. There's in transect, so seeing across, there's a little chicken house, there's some chickens, there's a swale and a food forest and a little forest system, and then we move to the same field further down. Looking at it from an angle, we also see that we've got a very carefully shaped forest around the outside that acts as a shelter belt, a protection, and as a sun trap, that the energy of the sun can be focused in this space. We've got our chickens, maybe this is a cooler climate. So we've got an assemblage of elements that meet the needs of the chickens. There's some fodder for them, there's the tree system for them, there's the house, and there's a little management thing. So strategic placement of elements to fulfill functions. Here's exploring the edges around buildings, thinking about the potentials of balconies, catching the runoff from roofs, channeling that into places where we can usefully use it, exploring vertical space, lateral space, hanging space, interesting edge spaces where it's a little bit sheltered and a little bit, maybe protected. Even around a window, if we can open a window, we can start to explore the edges. Could we have a window box or trellises going up the other side? Could we grow something across the top? The only upper limit is your own imagination. We can stack productivity and creativity into the landscape, food systems, water systems, shelter for animals, shelter for other beneficial species, so that we create a system which largely is self-managing, and we don't have to do too much work. We can train plants to be optimized for catching the sun. They can fulfill other functions like being barriers or looking beautiful or giving privacy or windbreak. Think about how the strategic placement of elements can help those then elements perform other functions. How this tree's been carefully managed and pruned, so it's just all in one plane. It just goes from side to side, up and down. There's no coming forward and back. So it fits very neatly into a small space, and yet gives us lots of capture and store energy, lots of edge, lots of surface area to gain from the sun. Growing things in pots. Yeah, okay. I'm going to pause because I think I'm rushing into this a little bit. We've got 20 minutes. I'm just going to pause. We can chat a bit, and also perhaps we can talk a little bit about how we're going to go through this design project part of the course as well. So hopefully everyone was happy with that. I saw Caroline dropped in and out a little bit. But yeah, the recording is there. So firstly, any questions or any points anyone would like to make in relation to what I've presented so far today?
Yes, zones and sectors play, a crucial role in the overall design process. But then sometimes you realize that through critical observation, you may realize that within your environment, probably, or within your locality or the community, you have bits of accidental, yet, proper or accidental kind of zoning. I was talking to one of the groups and I told them, this probably leads us to the fact that permaculture or natural systems mainly rely on the indigenous knowledge. That, yes, it could be, you could look at it as accidental, but then probably it's not. It's just that someone did it earlier. So also it reflects back to the segment where you're looking at also people's existing knowledge and previous projects as part of your input, or something that you can really observe and look out for. I think that's it for now. When Steve was showing that other image of the trees, we had a similar comparison, that those trees as windbreakers, that image of the tree rows. And we discussed the difference in case of a strong wind, if you have such a windbreaker or such a natural windbreakers versus, a wall or a brick wall. We at the end of the discussion, we realized that this is going to be with a brick wall. You're actually not slowing it down, you're just slightly deflecting it over, and it will land with even a harder force. But with such a design, a natural design or a natural pattern, you're slowing it down and you're not rather escalating it or creating. Maybe Steve could explain a little bit more on that dynamics of that.
Yeah, no, that's good. It's a good point. So something that's solid doesn't take any of the force of the wind out of it, does it? The wind's just going to hit it and then be directed in another direction. So it creates a buffeting effect where trees are going to sway. So actually they're absorbing some of the energy of the wind. So the air coming behind it is lifted up and over. because it's actually just taking some of the sting of the speed of the energy of the wind is dissipating some of it slightly, and that's enough to lift what's coming behind it up and over. So that flow, understanding how energy flows, it just moves from one state to another, doesn't it? It doesn't go away. I'm just thinking about that. It's interesting. So I want to challenge you all now to begin to think about how are you going to use this. I want you to apply these ideas that we're talking about to a real life situation. And it could be something small or it could be something more complex. Doesn't matter. Stella, you might just think of your backyard or not at all, or somewhere completely else. But Simon, I don't know what you have in mind of how you might use this. I mean, what I've seen with Deborah is many people have used this to design the compound around their house. So that might be interesting. But I'm going to ask you to think about, what are you going to design? What's the dream that you want to come true? And can we use what we're teaching you, a permaculture methodology, to do that? And maybe over the next few weeks, I can challenge you to begin your observation. Asking your client, even if that client is you, it might be your wife, it might be the family, it might be the people around, but identify who are we designing this for, and begin to think about what information you might need to begin this process. Look around to see what materials there are, and what do people regard as waste? Or is there anything, or do you notice anything being wasted, or what are the leaks? Okay, get yourself a little notebook. Write a few of these things down. Survey the client, survey the site, ask about the history, identify the leaks. That's your homework. That's what I want you to begin now thinking about. So who is the client? Well, it might be you, or it might be perhaps your family group, or it might be the users of your compound, or you choose 2 or 3, or you might come up with something completely different. And if you have trouble thinking of ideas, then we can talk about that. But I know that, for example, there's got the group at Natchivali. They want to do a community garden. I think that's a nice thing to think about. So where is it? Can we draw a little map of it? Can we be aware of the boundaries? What shape is it? How can we represent the shape and the slope of a piece of land? Get a sense of its size? And what's the soil like? Can we describe the soil there? What's it like? Is it hard and compacted? What plants are growing there already? What plants have chosen to grow there? Who used the land before you? What did they use it for? These are your observation questions. Can you start making some notes? Can you start drawing? It can be really sketchy and doesn't have to be tidy or anything. Make an approximate drawing of of the space that you want to design, and think about, we're starting from patterns to detail, so don't break yourself. Is it 20? It's about 20 or 30 meters, or it's 2 or 3 meters, or it's 10 meters. It's okay. Give me the impression. Oh no, it's 1,000 meters. Okay. We'll find exactly how many later on. We don't need to overinvest at the beginning, because we're ranging around, we're seeing the possibilities. Now, I liked in that one design methodology, it said, accept responsibility. Okay, you're in charge. Just imagine for a moment, if it was down to you or a group of you, is, okay, let's put ourselves in charge. Let's feel responsible for this situation. How can we work with it? How can we work with change in a positive way to create yields that are going to help meet our needs? what energy is there around that we can catch and store? Can we slow something down? Can we fold that into our productive systems? That's what you're thinking about at the beginning of your permaculture design. Anything else? Shame we haven't got a few more contributors to chip in. A really good way perhaps to start off your processes is this idea of look to the leaks, as in unused things that are maybe you could get more value out of, and that might turn out to be your key resource, because that's the thing that perhaps has not been valued previously. So remember, there's no such thing as waste. So if you see something that looks like waste, it's an opportunity. See how we might think strategically as designers. Remember, we talked about sometimes people are part of the waste. People aren't, are a fantastic resource. People with spare time, or people who want to learn something, or people who haven't got their own vision to know what to do. How do you build a relationship with them? How can design to inspire them about possibilities? So I think that if by going through this process and showing a vision of what's possible, that's actually how you then set that process in motion. That's my experience. And that's what we should be doing. So that's I think there's our really sort of thoughts on that for now. And as we are in session 13, we're going to begin now the observational process. Where's your opportunity for this? Who would the client be? And start asking, making some of those observations. Yep. Gerald.
Yes, Dave. Yeah, sure. As discussed earlier, and I think is maybe also from an accountant point of view, I would be, interested to see how to work out kind of an enterprise development design. And it would be interesting also to have probably a member or participants from the learning end switching roles and probably we become the clients and they are the professionals or the team that is working on that, or the designers. So that's something that I've been thinking about. But also, it would be, we can also switch roles. Yes. And as Steve has hinted, that this could also be helpful in shaping our teaching process or our enterprise model. Oh, Caroline is popping back in. So it would be really interesting to see that. And we can also switch tables and do bits of role play with, another team or another group. Yeah, maybe just to elaborate on this. And I think Steve hinted on it too. We're looking at permaculture beyond gardening. We're looking at permaculture extensively. So probably someone would be wondering, how does enterprise development end up into permaculture? We're looking at it more broadly. And if you've been a part of these sessions from whichever point you've joined, I'm sure you've realized that it goes beyond gardening. It goes beyond, farming and all that. Otherwise, if we restrict it to gardening, then we're nearly taking the agroforestry or the agriculture route. So let's look at it broadly. Your design could be beyond a garden. You could be designing a project to maybe hives, or you're designing, you could look at it more broadly. So it doesn't necessarily have to be a garden or a homestead. We can look or think far and wide. Steve, back to you. Stella, Caroline. Oh, Caroline, it's good to have you back. Sorry about the internet, and it's kicking you out.
Thank you so much.
Thank you for those thoughts. Yeah, so Caroline, we were just discussing about how we're going to apply what we're learning on this course, and wondering, challenging people if you have a design in mind, something you'd like to apply it to. But also, we'd like to hear more, if you would be so kind to tell us about the teaching that you're doing. I understand that you arrange training sessions within more than one location in refugee settlements, and you're teaching permaculture there. I'd love to just hear a little bit more about that, if you would be so kind.
Thank you so much, Steve. What I'm doing is that my first training, I did it in Kindu. That is a semi-arid area. And the demonstration farm there is just meant to show people that it doesn't matter the kind of environment you find yourself in. You can be able to grow your own food there, and not only your own food, even get abundance that you can share with the community. And this was achieved in about 2 months after we set up the demonstration farm. A family that was spending about £2 on vegetables daily was able to be self-sufficient in vegetables in a span of, let's say, 6 weeks. Yeah, after we did the demo garden, after 6 weeks, they could get lots of vegetables from the farm. And like in 2 months, they had enough to share. So that one was my first training in Kindu Bay, Homa Bay County. Then I started getting involved with Nakivale refugee camp. And when we visited there, the land is very, very degraded because the settlement is overpopulated. When people come, they chop down the trees because they need firewood, they need building materials. So another challenge the refugees are facing is lack of food and nutrition security. So we set up a demonstration garden in a church compound because we felt that the church compound is a public area. People would walk in and see what we are doing, and most probably replicate it in their homes. That is apart from the students who we are teaching, who of course are supposed to have the gardens wherever they live, no matter how small the compound is. So we are also engaged in that. So the next training that I'm having right now, in about maybe 2.5 weeks time, I'm doing it in a place called Migori County. That is actually where I live. But it's a piece of land that I bought. I've not yet, how do you say, done anything on it, there's no infrastructure, but we decided to set up a permaculture demo garden also there. The challenge in Migori is a bit different from Kindu Bay and maybe Nakivale. The difference here is that people do a lot of conventional farming. They use seeds that they buy, and they also use synthetic fertilizer. So the soil is degraded in that way. So my reason for having this training here and most probably a demo garden too is that we want to show them that there are different ways of achieving abundance. You can farm organically, you can use permaculture to create abundance in that you do not have to farm one crop, remove it from the farm, and at other times you find there's nothing on the farm. Another thing that we really want to tell them about is the heirloom seeds. And especially in Kenya right now, where we are having this issue of the government has outlawed seed saving and sharing. So this year's training, the theme is our seeds, our heritage. We are just telling the government that no, you cannot remove the power of our growing our own food from our hands. We need to strongly hold on to that power. And we can only do that. We can only do that when, we can be able to do seed saving and sharing amongst ourselves. The other thing in this area that we also really wanted to tell them is that synthetic synthetic fertilizers messes up the soil systems. So we are hoping that we will be able to spread this message. And like today, I was just talking to one of the government leaders, who's in charge of the area where we are having the training. And this gentleman told me, can men come and attend the training? And I told him, why not? So long as the ladies are more than the men, we don't mind. And he asked, can I come and join? I'll be on leave at that time. And I told him, go ahead, just prepare yourself. You have to come in the morning, leave in the evening. So I'm thinking that people are already changing their outlook. They are changing the way they do their farming. And for me, because that is the place where I intend to build my home, well, I think it's an exciting journey that that I'm starting on this particular piece of land. Yeah, thank you.
Thank you so much for that, Caroline. It's really fascinating, and we must create more space now too. I want to hear. I've done all this talking now. I'm going to try each week, and I want to, sort of get more back from you. So, thinking about questions. I'll end now because we've used our time up. But Simon, we're going to invite you and the others. Tell us more about how you want to use permaculture, what challenges you feel you're facing, or opportunities do you want to explore, and think about how we're going to use these ideas as in a design sort of framework. So and so anyone else is tuning in as well, is this is our homework for everyone now, is begin to do your observation, begin to think about who's the client, what are our challenges, what are the functions of the design we want to do, and yeah, start finding some of those details. So I'm going to say thank you very much, everyone. We'll be at the same time next week. We will now stick to, sorry about the confusion with the time change, but we'll stick to our to this time now. And I'll say goodnight to everyone, and a chance for anyone else to any closing thoughts?
Thanks, Caroline. That is really inspirational and timely. And yes, probably you're on the right course at the right time. And it would be interesting to have that as your design project. And probably one of the outputs of the course is sad. And, you know, I don't want to lament, but some of our governments or some of those politicians are really evil, and the way they are insisting on, you know, on things which should be meager, like banning seed saving and sharing, whereas leaving out the bigger crisis and the dangers that are, you know, all around us. But I don't want to go political, join the lamenting club.
Well,
yeah, so
Gerald, I'll go. Sorry, just to butt into your thing. I'll say one thing is, it's often conditional of overseas aid investment packages, and it's the big agro-business seed companies look at African nations and India as just as a market to sell their branded products to. So they don't want you saving seed. They want you to buy GM corn that's got a patent on it. So sadly, it's and the governments are strong-armed as well. So it's not always the fault of the governments, but it is the fault of large corporations who just want to make profit out of growing food.
Wow, sad. Yeah, so it's been a pleasure. It's been a very interesting session, very informative, and thanks everyone for the participation. This is a very interesting phase we've gone into, very interesting, and yes, we're looking forward to lots of participation. Unless anyone else has a comment, we will end it at this point. Simon.
Okay, bye everybody.
Okay, Caroline. Thanks.
Bye-bye.
Thanks, Caroline. Bye-bye.
Bye, everyone.
Bye.
Thank you. Bye.
Bye-bye.
Thank you.
Bye.